Okay, we're going to look at scalars and vectors. A few questions. Describe the difference between a scalar and a vector. Number 2, what must vectors obey? Well, vectors need to obey something. And number 3, define and describe the classifications of vectors. Describe the different classifications. Okay, scalars and vectors. Scalar quantity only has a magnitude. Right? Examples are time, volume, density, speed, energy, mass. Scalar quantities only have a magnitude. Vector quantities have a direction as well as a magnitude, direction and magnitude, and must obey the parallelogram law of addition. Okay, we'll get to that a bit later, but for example, if you've got a vector there, let's call it just v1 and v2, the way that you add these vectors is by using the parallelogram law of addition, right? That would be v1 plus v2. So you can't simply take their magnitudes and add them to get the magnitude of the final vector. That's not right. It needs to obey the parallelogram law of addition, okay? Vector quantities, what are they? Displacement, velocity, right? You have speed, which is the magnitude of velocity, but speed is a scalar. Velocity is a vector. Acceleration, force, moment, momentum. Okay, now how do we classify vectors? How do we classify vectors? Three types of classifications: free, sliding, fixed. Okay, free vector. Okay, free vector does have a magnitude, of course, and a direction, but it can be placed anywhere. That exact same vector can be placed there, 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 right? It has the same magnitude and its direction is the same, but it's free to be placed anywhere. So the example they give over here is that if you've got say some object that is moving, but it's not rotating at all, then every point on this object goes through this in a specific time interval. Every point goes through the same displacement. So that point, as this object moves to, say, there, that point moves to there, that point moves to there, that point moves to there, right? So each point has the same displacement, right? The same displacement vector. So it's a vector with a magnitude and a direction, but it can describe any point. It's a free vector. Later on as well, you'll see that a couple, I'm just priming your mind now, a couple is also a free vector. Its action is not confined or associated with a unique line in space. Okay? It can be it's got a magnitude and direction, but not a unique line. Okay. Alright. A sliding vector does have a unique line of action. Okay, so it's not a free vector. It's a sliding vector. You've got an object here, say a rigid body, and you apply a force there, say, for example, a force vector. Then a sliding vector means that, well, first of all, this has to be a rigid body. Did I mention that it has to be a rigid body for this to be true? you can apply this force at any point, right, along the line of action of this force, right? And it will have the same external effect on this body. So whether you apply the force there at that point, you apply it there, you apply it there, it will have the same effect, external effect. Yes, it will have the same external effect on this body. Okay, so it says here, it can be applied any point along its line of action without changing its effect on the body as a whole. Okay, what does that little star say, that little asterisk? This is known as the principle of transmissibility. Transmissibility. Principle of transmissibility. You can apply this force anywhere. But although we're not talking about forces here, we're talking about vectors. Force is a vector. And then a fixed vector is more constrained because a fixed vector doesn't allow you to apply. Well, first of all, a vector has a magnitude and a direction. A sliding vector constrains you to be applied along this line. But a fixed vector not only constrains you along this line, but at a point. A fixed vector is you apply it at a specific point. You can't just apply it anywhere along the line of action, but at that specific point. And it's very important to use fixed vectors when we are dealing with deformations within a body. Okay? So see if you can define and describe these, and see if you can answer those questions.